Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Nowadays, we are living in an era which technology is advancing. So many modern electronic devices can help us to do everything such as computer, television, smartphone, and etc. All of them is inseparable from electrical energy storage device. One of electrical energy storage device is capacitor, which has a dielectric material inside. To store greater electrical energy, how dielectric material has a high dielectric constant? Yeah, we need smart material. Based on many research, ferroelectric material is the best one. So, let me introduce myself. My name is Ulfa, and today I will present the result of our research about ferroelectric material. The title and also the aim of our research is to determine microstructure, morphology, and dielectric properties of barium, lanthanum, titanat with variation more concentration of lanthanum by co-precipitation method. Ferroelectric material is material which possesses spontaneous polarization, which can reverse by suitable electric field. Relation between polarization and electric field shown in figure 1 as hysteresis loop. Raw material that we use is barium titanat. We choose barium titanat because barium titanat has a high dielectric constant, has ferroelectric and piezoelectric properties, has stable chemical, mechanical, and electricity properties, eco-friendly, and has temperature Curie 120 degrees Celsius. Barium titanat has a BO3 perovskite structure. A is the bigger cation in the corner of cube, it is barium. B in the center of cube, it is titanium, and O in the middle surface of cube is oxygen. This is radius of barium, lanthanum, and titanium. It shows that barium and lanthanum have almost the same radius, which lanthanum has smaller radius than barium. Synthesis method that we use is co-precipitation method. It is chemical method by combining two or more types of different solid and liquid material. We choose co-precipitation method because it low cost, easily operated, homogeneous, a controllable product morphology, and the important one is no safety risk. This is several tools and material that we use. This is the sequence of co-precipitation method. First, we have to prepare our raw material. They are oxalic acid, barium hydroxide, titanium tetrabutoxide, and lanthanum nitrate. Dissolving oxalic acid into isopropanol, titanium tetrabutoxide dissolving into isopropanol and mix to the first solution, and they form oxalotitanic acid. Barium hydroxide and lanthanum nitrate with variation concentration mole of lanthanum 10% and 15% were added into oxalotitanic acid, and aqueous were added to oxalotitanic acid by titration. Mixture kept overnight under hydrolysis with temperature 100 degrees Celsius, and then grinding and sintering at variation temperature 1300 degrees Celsius and for 1400 degrees Celsius, holding time 4 hours. For the next step is characterization. There are 4 kinds of characterization. First is XRD characterization for analysis crystal structure, crystallite size, and crystallinity. The second is scanning electron microscopy or SEM to analyze morphology and grain size of sample, and then RCLmeter for analysis dielectric constant, and the last is Sawyer tower for analysis hysteresis properties. Here we are in the result and discussion. This is the result of XRD characterization. It shows the relation between intensity and diffraction angle. We are identify the peak with matching by matching with ICDD data from the figure 1. So the barium, lanthanum, titanat with modified lanthanum 10% still has other peaks and it's owned by barium carbonate, and for 15% it has single phase, and it means that the barium, lanthanum, titanium, and oxygen have diffused completely. Lanthanum can replace barium atom. Lanthanum has smaller radius atom, so the more lanthanum modified barium, it will change distance atom, so the lattice parameter will decrease and lattice strength will increase, and it also affects the unit volume shell. the unit volume cell will decrease, so that crystallite size will decrease too. And this is the result of SEM characterization. This is the photo of SEM with magnification 5,000 and 50,000 times. It shows that the more lanthanum modified into barium titanate, the grain size of the sample will decrease. For the D figure, so that the grain size is very small. It is the photo SEM of barium lanthanum titanate with variation concentration mole lanthanum 15% and sintered at temperature 1400 degrees Celsius. And this is the result of RCLmeter characterization. This is the relation between dielectric constant and frequency. It shows that the increasing frequency, the dielectric constant is decreased. It because one input frequency is low, the negative charge oscillates with the same frequency as the dielectric field given, where the direction of dipole can adjust the direction of the electric field so that the dielectric constant was high. When the frequency given is too high, the dipole cannot follow the electric field, so that the dielectric constant decreases. Table 3 shows the dielectric constant of barium lanthanum titanate. The dielectric constant is influenced by concentration of lanthanum. The greater concentration lanthanum modified into barium titanate, the more dielectric constant of sample increase. This is the result of a Sawyer-Tower method. It is a hysteresis loop. Its loop that for the figure 4D has a highest polarization. It is owned by sample barium lanthanum titanate with modified lanthanum 15% at sintering temperature 1400 degrees Celsius. It means that the more higher polarization, the more dipole moment are obtained. The more dipole moment are obtained, the more charges are stored. And this is the conclusion. The greater concentration of lanthanum added causes the diffraction angle shift to the right, and then crystallite size gets smaller as the concentration of lanthanum is added, and the sintering temperature increase. From the same result, so that ground size gets smaller with increasing lanthanum concentration. And from the RCLmeter characterization, so that the dielectric constant will increase with the increasing lanthanum modified into barium titanate. The highest dielectric constant is owned by barium lanthanum titanate with modified with lanthanum 15% at sintering temperature 1400 degrees Celsius. The highest dielectric constant is 414. And this is our reference. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.